We'll proceed in partial Jacobian and full Jacobian. Three Jacobians we are in discussion with. One is cross Jacobian, partial Jacobian, full Jacobian. Why this much emphasis we are giving in for the Jacobian? Jacobian is something that is considered as pioneer in calculus. It has vector, it has algebraic vector, it has vector, it has algebraic vector, it has algebra, it has calculus, it has different coordinate system, and then the derivative against one coordinate system to other coordinate system. Amazing. If I am able to derive a particular algebra with respect to another coordinate system, this is what we are seeing in Jacobi. Not only that, this, this derivative is single dimensional, surface derivative, volume derivative, n dimension. So till now, the Jacobian we can consider as the most advanced topic we are seeing in calculus. How it will be used in machine learning, artificial intelligence, that we will see. Okay, so we will proceed with the kind of a partial Jacobian and full Jacobian while calculating the volume of a sphere. Okay, so that is the scenario. So uh, I have a sphere. Okay, I have two spheres. One is green apple. This is a sphere. This is a sphere, kind of a sphere, and I have another one, and it is not kind of very smooth. The way it looks like, it is something like a asteroid or some natural satellite of some planet. So it is not pure round, but it is more or less a spherical. And this is also a spherical. What we have discussed now, we have already calculated the, the surface area of a cone, surface area of a cone with the cross Jacobi. This is my cone. Okay, so this is a typical kind of clay uh, uh, cup or glass in India, and people they drink, drink tea and coffee anyway. I don't drink tea or coffee, but this is how it is, and it is with me because I'm using as a music system. I place a speaker on top of it, and then it really vibrates very nice. That's how it is with me. Anyway, so this is a kind of a cone. It's a conical, and if this portion goes beyond, then it becomes a full cone. And if I tilt it like this, and then it goes like this and become a cone, then this is called right cone, right angle cone, because this is touching the xy plane, and then from here the radius is a and height is h. The angle between that is 90 degrees. So this is right angle cone. Okay, so we have, if you right angle cone, how to calculate surface area, that we have seen, that is pi a into the slant length, that is s. Pi a s is the surface area of the cone. How we calculate it through cross Jacobian, that someone can buy. So that is amazing, mind blowing. Cross Jacobian, partial Jacobian, full Jacobian. Everywhere the full Jacobian is something that is mentioned. Partial Jacobian and cross Jacobian is our fundament. Anyway, so now we will try calculating the volume of a sphere. How to calculate volume of a sphere? Now, if I have xy plane, okay, if I have xy plane, this is xy plane, and this dot is origin. If this is xy plane and this dot, this dot is origin and this is xy plane, then this is centered at the origin. So this I can pierce, this I can insert it, and this will be centered at the origin. Now what is the volume of this sphere? What is the volume of this sphere when it is at height h? Then what is the volume of the sphere? Okay, what is the equation of a sphere? What is the equation of a sphere? X square plus y square plus z square equal to a square. Z equal to square root of a square minus x square minus y square. Is it the same equation that is valid for this also, this also, this also, this also, and then centered at the origin? Certainly not. This equation is for a sphere that is centered at the origin. Then what is the equation of this sphere? X square plus y square plus z square. X square plus y square z square equal to a square. Now, along the x-axis, there is no shifting. Along the y-axis, there is no shifting. But along the z, this is shifted toward the z-axis. If it is at height h, then z minus h. So it will be kind of z equal to square root of a square minus x square minus y square. Since it is at height h, its center is at height h. Now it is z minus h equal to square root of a square minus x square minus y square. Z equal to h plus square root of a square minus x square minus y square. In electronics terminology, this is called placing a DC, placing a DC component or offset. So whatever the z equal to square root of a square minus x square minus y square, if I add h, whatever comes, add h, so that it will be have h height. So that is the kind of equation of the, no, we are not considering. If it is at height h, what is the volume? Consider fxy, function over x and y. Xy, this is xy plane, this is x-axis, this is y-axis, this is z-axis. If this is xyz plane, then if this is xyz plane, then what would be the kind of fxy? Function over x and y. Here it is h plus square root of a square minus x square minus y square. fxy integration with dxy plane. fxy integration with dxy plane. Fx function over x integration with dx. What is that? Can you please tell me? So if this is x-axis and over it there is a function over x, there is a curve, then what is this? Whatever is the area underneath this curve is the integration. So if there is a, okay, if there is a x-axis and there is a curve, this is a curve, this is placed like this on the x-axis. Whatever the area underneath this curve, that is the integration. If it is height here, then from here to here, I am calculating the limit. The lower limit is this, higher limit is this. Underneath whatever comes going to x-axis, full is the area. DC component area, rectangle area is added. Similarly, if I drop it, whatever the volume it is covering, full, this sphere plus this cube. After that, from here it is a cubicle, and it won't be cubicle. I mean, a spherical, a circular and height. This is what I believe. So. Whatever the sphere plus whatever the height we have taken, that much volume it would calculate. Fxy dxy plane. Fxy dx dy. This is the surface of a sphere integration over a xy region. Now this sphere, now if it falls, then it go and maps on the xy plane, and that mapping is a circle. That mapping is a circle. So I have to integrate along a circular region on xy plane, but we are not going to do that one. This sphere is centered at the origin. So fxy equal to square root of a square minus x square minus y square. H is gone. Okay. So fxy dx dy. This will give volume of the upper hemisphere of the sphere. If this sphere has top hemisphere, because it is centered at the origin, it has two parts. One part is above the xy plane and another part is below the xy plane. So top hemisphere is, is what we are calculating. It is a Cartesian coordinate system, xy. Now, the integration limit is a circular region on xy plane with radius a, that is the radius of a sphere, fxy, dxy plane, dx dy. What is fxy? That is square root of a square minus x square minus y square, dx dy. If ask someone to calculate this integration, he would start certainly sweating, or he will start seeing star in the daytime. So it is, that is kind of little difficult. If that is a scenario, then any would suggest to go with different coordinate system. What coordinate system I can follow? So people would suggest that go with the kind of polar coordinate system. Okay, I don't know. So that is the concept anyone should think. I don't know what is polar, what is, this is the idea of Jacobian. When Jacobian comes into the picture, then generic idea comes into the picture. There is nothing fixed that it should be a polar coordinate system or it should be Cartesian coordinate system. It's nothing. A square minus x square minus y square. It looks like if I set x equal to r cos theta and y equal to r sin theta. Why I took r and theta, two independent variables, because x and y are there. Then it becomes a square minus r square. Theta is gone. Looks pretty. Alright. And there, now dx dy, I have to set d theta dr or dr d theta. But it's not that straightforward. There are three parts in integral calculus. One is limit, one is integrand, and one is differential. Integrand, quickly I can check. So what, square root of a square minus x square minus y square. If x equal to r cos theta, y equal to r sin theta. Why I am saying don't go with the polar coordinate? This is polar coordinate. But don't go with polar coordinates. Do whatever is the ethics comes to someone's mind. If someone's mind is saying this is the proper way, please proceed. That's why we are here. We are not here that okay, it is matching polar. Let's go with the polar. If you go with the polar, the limit is very easy to set because polar is a circle, and then r is from 0 to a and theta is 2 pi. Simple. And then dx dy is an area on xy plane. The area on r theta plane, it will be r d theta dr. 1 minute. But not necessarily every time. We'll see. Every time we land up in this situation, how many coordinate system you would mug up? Not possible. So if we think that r cos theta, r sin theta can solve our problem, I don't know what it is, polar coordinate system or whatever it is. Let's proceed. The square root of a square minus x square minus y square would be now a square minus r square cos square theta minus r square sin square theta, square root of a square minus r square. Dxy, that is dx dy, can be written as dxy by dr theta into dr theta. So dr theta becomes dr d theta, where dxy by dr theta is called Jacobian, that will be attached separately. Because x is not r, x is not theta, and y is not r. If they were exactly same, then it would have been dx dy, directly I can set it to d theta dr. Or x equal to 10 theta, x equal to 10 theta, y equal to 20 r, then 10 into 20 d theta dr. But here x equal to r cos theta and y equal to r sin theta. It is looking something weird. It is looking something that is non-linear. If that is the case, then we say dxy plane by d theta r into d theta r. D theta r I can say d theta dr. Dxy by d theta r is called conversion factor that I need to attach now. It is also called Jacobian. What is dxy by d theta r? Many times we have demonstrated it. So, what is the current scenario now? I have fxy and xy plane. This fxyz is dependent upon the xy plane. If I have xy plane and a circular region on xy plane, from this circular region, not outside any, I will take x point and y point only on this circular region. Okay, if I take x and y point only on this circular region, then inside this circular region, if I take any x and y and then set it to square root of a square minus x square minus y square, every point would go and it will kind of match to a point in z axis. If I connect all, it becomes a surface that will be like this. Okay. Now the scenario is fxy. We are in phase of calculating volume of a sphere. Now I have a fxy. I have fxy, and this is xy plane. Now, now if this is xy plane, this is xy plane, then there is another plane coming into the picture called theta r plane. Xy plane, theta r plane. Above the xy plane, we have fxy. So fxy is dependent upon xy. Xy plane is dependent upon theta r plane. Xy is dependent upon theta r plane. If that is the scenario, then how we can proceed? So now the concept is if this is theta r plane, xy plane, xy plane is dependent upon theta r plane. Or if this is theta r plane, then xy plane is here. If this is xy plane, then z is here. That is the surface, that is the sphere. Okay, in that case, this is theta r. But if it is theta r, then xy is here. Xy plane is dependent upon theta r plane. If I take any point on the xy plane P, any point P, then dp by d theta cross dp by dr, dp by d theta cross dp by dr, any point P, if I take, its position vector is P vector. dp by d theta, dp by d theta is now if that is the case, if this is xy and this is theta r plane, then this is theta xy plane, theta xy plane. This is this is this is theta. In this, if this is theta r plane, this is theta, this is theta, this is r, this is xy. Now this is theta xy plane, this is theta, this is theta, this is r xy plane. Now if I take any point here P, if I take any point P on the xy plane, then this P is xi plus yj, xi plus yj. Or if I consider two coordinate system, this is xy plane and this is theta r plane. Now if I draw any rectangle on theta r plane, rectangle, this rectangle would go and map as a circle in xy plane, because x equal to r cos theta and y equal to r sin theta. In xy plane, we can imagine theta r is like a circular region where a radius is rotating like this. So this rotation angle is theta and r is like this. But if we go to theta r plane, this is a rectangle where x-axis is theta and y-axis is r. It is a pure rectangle. It has nothing to do with circle at all. This rectangle is mapped like a circle in xy plane. So xy plane and theta r plane both are Cartesian. But the way their transformation relationship is there, the theta r plane, if I try to see in xy plane at the same time, then then in that case it becomes a circle. So x and y, theta and r, if I want to see all hold together, then theta r behaves like a circle. But in theta r plane, if theta r is a different coordinate system where x-axis is theta, r-axis is y-axis, then it is a rectangle, simple rectangle. What is x and y mapped over there? Someone can think like this. But if it is x and y coordinate system is there, if a theta and r, if I map this rectangular region here, it becomes a circle. Dxy plane by d theta r means dxy surface by dxy surface by d theta r surface. In xy plane, the surface is a circle. Here surface is a rectangle. If I make unit change of rectangular area, if it is mapped to a circle in xy plane, how many unit change I can see area in theta r? So here area is rectangle, region is rectangular and region is circular. Rectangle, if I make one unit of change, either grow or shrink, how many unit of change I can see in this area? dxy by d theta r, dx by d theta. If I make one unit change in d theta, then how many unit change it brings in dx? X, dx by d theta, dxy by d theta. Okay, if two things are coming, it resolves in an area. If there is a rectangular region in theta r, if there is one unit of area change, meter square, centimeter square, whatever the unit is, how much unit area it changes in xy plane. Now, if I consider this a theta r plane, and this is xy, if I take any point position vector on xy, that is p, then dp by d theta cross dp by dr. dp by dx is a vector. dp by dr is a vector. If I take cross product of these two vectors, then it gives me this surface area in xy plane by d theta r. This is what we want. Okay, please watch our past videos. This is what we calculate in typically calculating the surface area in pure Cartesian coordinate system. If it is xy plane and if I have a sphere and on the sphere that is fxy, if I take any point P here, dp by dx cross dp by dy gives d surface area on the sphere that is z-axis by dxy plane. Similarly, if I take point P on xy plane, dp by d theta cross dp by dr gives the d surface area on the xy plane by d surface area on the theta r. So P is xi plus yj. So dxi plus yj by d theta cross dxi plus yj by dr. That we have to calculate the value. It is called Jacobian. So if I take x equal to r cos theta, y equal to r sin theta, then dxi plus y, dr cos theta I plus dr sin theta j by d theta. It would result in r minus sin theta I plus r cos theta j cross with xi plus y dxi plus yj by dr. It would resolve in cos theta I plus sin theta j. If you do cross product, then it will resolve in r cos square theta plus sin square theta r. So now we had earlier the equation was fxy dx dy was giving the volume of top form sphere. Now fxy, that is square root of a square minus x square minus y square, that I changed it into x equal to r cos theta and y equal to r sin theta. Mind it, we are not taking help of polar coordinate system. Everything is through mathematics only. So now it results in square root of a square minus r square. Now dxy is dxy by d theta r into d theta r. dxy by d theta r is nothing but dxy as a position vector. Okay, because d surface area in xy by d surface area in theta r. This is what we are doing. When surface area comes into the picture, then it is cross of two vectors. Because cross of two vectors gives the surface area in between. So if xy surface, if I take any point P, then dp by d theta cross dp by dr. The surface area in xy plane by d theta r. That is the scenario, it is r. R d theta dr. So r into square root of a square minus r square d theta dr. Now the limit is a circular region because the sphere go and map like a circle on the xy plane. Filled circular region, not the circumference. Filled circular region where x is minus a to a and y I cannot say minus a to a. It is circular region. It should be rectangle. Repeatedly I am saying when the limit is a circle non-rectangular region. If it is a rectangular region, then it is straightforward. Minus a to a, minus b to b, minus a to a, whatever the y is. They are independent to each other when they are rectangular. But if it is not rectangular, then x, y are collinear. They are dependent upon each other. Like if x is minus a, x is minus a to a, then y is minus a square root of x square minus a square minus x square to a square root of plus a square root of a square minus x square. A, x and y are related to each other. This is what is the problem. They should be unrelated. Now it is a circle that is non-rectangular. They are related to each other. Where x if I take as a kind of numeric value, then y is in function of x. So x is minus a to a, then y is minus a square root of a square minus x square to plus a square root of a square minus x square. Okay, if that is the case, now we will resolve this limit. Now y equal to minus a square root of a square minus x square to plus square root of a square minus x square. Okay, now this is for the circle and this is for the top hemisphere. Let's divide this circle into again two parts. Upper half of the circle, lower half of the circle. If that is the case, then x is still minus a to a, where y is 0 to a square root of a square minus x square. Now y is r sine theta. So y square equal to a square minus x square. X square plus y square equal to a square. Then r square sine square theta plus r square cos square theta equal to a square. Okay. That is the case, then r square equal to a square. R equal to a. So 0 to a. If y is r sine theta and y is 0, I mean y equal to 0. That is r sine theta. 0 equal to r sine theta. R is 0. So 0 to a is the r. What about theta? Minus a to a is the x. Now y equal to r sine theta, x equal to r sine cos theta, y by x equal to tan theta. Theta is tan inverse y by x. Now y is minus a and y is 0, where if we take x limit at that point y is 0, where x is minus a, x is a, minus 0 tan theta, minus 0 sine, minus 0 tan inverse, minus plus 0 tan inverse. One is pi and one is 0. So theta will go pi to 0, not 0 to 2 pi. Mind it. This is different. So theta would go 0 to pi and r would go 0 to a. This is pure numerical and looks like a rectangular region. Now r square root of a square minus r square. This integration would resolve in, I believe, minus 1 by 3 a square minus r square to the power 3 by 2. Because if I differentiate it, 3 by 2 a square minus r square to the power 1 by 2 and then minus r minus 2r. 2 got minus 2r. Okay, I'm sorry, I'll try again. I'm saying minus 1 by 3 square root a square minus r square is the integration of r square root of a square minus r square. If that is true, then a square minus r square to the power 3, if I differentiate 3 by 2, if I differentiate, it becomes 3 by 2. A square minus r square 1 by 2 into minus r square will resolve in minus 2r. So minus gone, 3 3 gone, by 2, 2 gone. It becomes same. So minus 1 by 3 square root of a square minus r square is the integration. Now r is from 0 to a. So a if I push, then 0. 0 if I put, then 0 if I, no, the integration is okay, a square minus 1 by 3 a square minus r square to the power 3 by 2. Limit is 0 to a if I put, then r as a, then 0. 0 if I put, then it becomes a square to the power 3 by 2, a to the power 3 minus 1, and 0 was lower limit. Okay, lower limit, whatever, minus minus gone. Lower limit means minus I have to keep. So a by 3 by 3 and theta, and theta integration is d theta is theta pi to 0. Okay, it becomes, I believe we are doing something wrong. I believe there is a problem in sign. Someone should settle it. Anyway, so theta pi to 0 means pi a to the power, pi a to the power 3 by 3. So pi a to the power 3 by 3 is the volume of a sphere. But we had taken top hemisphere. In that also reason I had taken upper half of the circle. So full circle will be multiplied by 2 and then multiplied by 2. 4 pi a to the power 3 by 3. 4 pi 4 pi a to the power 3 by 3. Okay, this is the volume of a surface with full Jacobian. Now, someone can try the partial Jacobian while calculating the volume of the sphere. We will try it. I can provide a hint on it. So, if I am saying there is a circular region on xy plane where x is minus a to a and y is minus a square root of a square minus x square to plus a square root of a square minus x square. Integrand is square root of a square minus x square minus y square dx dy. So someone can proceed in x. Someone can proceed in x, and then only one substitution, method of substitution in integration. So only one substitution we can afford, not the dual. So if I'm going with x only, then d consider. So now square root of a square minus x square minus y square can be written as square root of a square minus y square minus x square. X, I can take x equal to square root of a square minus y square cos theta. X equal to square root of a square minus x square cos theta. Or I can try with the y. dy first, dx later. If that is the scenario, it is square root of a square minus x square minus y square. Y equal to square root of a square minus x square cos theta. So dy is nothing but dy by d theta into d theta. Dy is dy by d theta into d theta. Dy by d theta is the Jacobian. D theta anyway we are getting. If y equal to square root of a square minus x square cos theta, dy by d theta equal to square root of a square minus x square, that is constant, minus sine theta, that we can put there. If we put there like this, then it becomes, the dy becomes now minus a square minus x square sine theta d theta, and inside it a square minus x square minus y square. Y square becomes a square root a square minus x square cos square theta. I can take out a square minus x square root. So square root a square minus x square root 1 minus cos square theta. So sine theta. Sine theta here, sine theta there. Sine square theta. A square root of a square minus x square there, here also. So minus a square minus x square I can keep outside, and then sine square theta d theta. I believe someone can proceed on it. Okay, please don't forget to support us. So our telephone number is +91 9483160610. India country code is +91 And then phone number is 94831 60610. So please proceed on calculating the kind of volume of a sphere through partial Jacobian. This is also amazing because it is simple. Which one is better? Cross Jacobian, partial Jacobian, or full Jacobian? Whatever it suits the situation and scenario where someone is deft at. So that is also the case. So that someone should try.